Hello everyone, welcome to the Seaborn's Part 2 lectures. So in this lecture, we'll be discussing the difference between a matplotlib versus a Seaborn in the plotting code area. So this gets even more evident when trying to draw a statistical plot, which is often the case in data science domain. And for this purpose today, we shall take an example of a linear regression plot. But before we get into action, let me highlight another important aspect relating to aesthetics of a Seaborn plot. So, if you have installed a Seaborn version 0.0 or above, which certainly will be the case if you have installed it lately or updated Seaborn anytime after June 2017, then the plot doesn't necessarily seem to automatically separate the value representations. So let us first see an example here. So always the first is to import required packages or libraries. Here we have 4, and then so noticing that this is the magic function that we talked previously. So if we just import warnings, so the current version of Seaborn generates a bunch of warnings, but we'll ignore it in this tutorial. So we just do the warnings.filter warnings, which is the ignore. And in this case, all the things here just helping us to ignore any warnings possible. And then we just simply manually create a hypothetical distributed data set. So we use a NP, which is an appended array here. It just generates a random normal like distributions with the size of 100. And this is we just displays the plot, distribution plot, and then we just plug in all those x here, which is the random numbers, and then the bins are 20. So like the 20 of them are like form one each bin. And then the KDE is true, RAG is equals to true. Well, just to mention again, the warning above is harmless as it just shows a particular argument has been depreciated in current version of Seaborn. So we just, just do like ignore all those warnings, so which is totally fine. But the thing, another thing to observe in this histogram is that each bar is closely attached to another, right? So this is like really hard to tell what's the difference between these two. You may read, okay, so these is the beans, right? So this is like only 20 forms the bean, but actually there are two consecutive beans that is really closely adjacent to each other. So, and though this might be the latest enhancement of Seaborn, many professionals who are like you and me still like the old matplotlib style of the bar separation. So here we shall try to draw separators between each bar. So what you're going to do is you're going to use this one here. So noting that histogram keep study is equal to this setting the H color here, and then we set the line width. So basically this just helps us distinguish all those lines. So now we can see clearly right here, they are separated, right, compared to the previous plot. And then so now, like just once again, we have each bar visibly separated, and that gets more appealing to us or to the professionals. Then now you know how to get this done. Okay. And another important change that happened to the version 0.2 was in terms of the limits of access right here. So let me just show you an example of what we mean here. So say, for example, we're loading a building data set of a Titanic, and we create a distribution plot using distribution plot here. So we're just gonna use passing the data for the Titanic's age column, and then we're gonna drop any NaN values may appear in this column, and then we're just setting all those like separate histogram bars using this kind of here, right? So you may notice in the above plot that axis is in particular doesn't start with 0, right? So this particular line here. So many a time we would let it be this way, but for some reason, if we strictly want a plot to begin with 0, what you're gonna do? We're gonna require another additional line of the code to cite the limits, which is here. this is going to be the same for our matplotlib syntax. So this is going to set the x limits, which is the x-axis limits, to 0, starting from 0 and then until 100, were the biggest values that we are interested in. So now this here starting with 0. So the least pass defines the lower and upper limits of our x-axis are this least here. So if required, similarly, we may set limits of our y-axis as well as by adjusting, adding another line of the code, which is here, but this time we're changing to y limits. And this we're going to pass the lower and upper bound using this list. So that pretty much covers the leftovers for us in terms of estimates of our plots. So now we shall look into our long-awaited code length computation. Just kidding. Well, so let us begin plotting our matplotlib plot for regression. And then here it is the codes. So basically, we're just creating random data points for our x values and our y values, right? And then we're going to use the polyfit function for us to fit a regression. And noticing that this fit fn here is not a function which takes in x and returns an estimated for y, right? Here. And then we're going to plot it, and then we're going to set a label, and then we're going to remember these are for the x and y axis limits. So this plot here is what we're going to generate using the matplotlib code. All right. So any linear regression plots in general linear attempts to model the relationship between two variables. So x and y here by fitting a linear equation to observed data. So one variable is considered to be an explanatory variable, and then the other is considered to be a dependent variable, right? So y here is what we call our dependent variable, and then this is here the value of x is we call an explanatory variable. So say, for example, a data analyst may want to relate the weights of individuals to their heights. And if we're going to use a linear regression model, we're going to use the weights of the individuals. It's the y-axis, and then the heights are their x-axis, right? Okay, so what we're just going to do is just a simple linear fit that we're trying to achieve with our example. And so having read what we have here for matplotlib, let's jump into our Seaborn. This is really, really nice and easy format, right? So we're loading or generating this using our data sets that's available here, which is our tips data sets. And then we're going to use the regression plot function here. And so what we are passing for x is something or some attributes in this tips data sets, which is the total bill, and then the y as the tips. Okay. And then the status is equals to tips, which is this, which is our data frame here. Right. And then let us also have a quick preview with different color of this plot. Right. So we are just using our built-in data sets for our tips. And then if we're going to choose colors equal to R, so R just stands for red. So this is what our Seaborn yields to us. So before we move on to our next lecture, let me show a Seaborn plot against a matplotlib plot, which might be a little bit complex at this stage, but as you keep discussing more and more in our projects or subjects, at least the Seaborn segment of it will get clearer for you. So in today's agenda here, we'll just to look or just to have a little bit pick over the plot and then not focus on the code associated. Right, so this one here, we're just using a pair plot right here. So this just generates how variables or different variables have correlations with all those different variables, right? So these are the next graph that Seaborn generates for us. Now let's get to do the same thing using matplotlib. And the difference in the semantics should be a great, booster for you to stay glued ahead of this statistical visualization Bible with Python. Okay, so we're making a pair plot, which is kind of redundant using this matplotlib because it doesn't have a built-in paraplot for us. So what we're going to do is we're going to set all those set plots. So each individual of these plots are called subplots. So that's why we have a number of columns, a number of rows here, and then we don't hard-code it, right? So this one we can change it above. And then for each different plots, we're going to plot it, and then there's a bunch of the parameter here. So we don't necessarily have to focus too much attention here, right? And then just don't forget, we have the plt.show function so that we can see this whole graph. And as we can see, like this whole graph is generated by matplotlib, while these whole plot here, like really clear and precise and beautiful, are, is simply just what Seaborn offers. So there's quite a bit of difference that we can observe in both of the plots above, in matplotlib and then for the Seaborns. So for the matplotlib codes, would require more lines, as you may have noticed that. So it would require some more lines of code or parameters. And here, Seaborn gives us the flexibility to achieve the same with the minimum number of lines of code. And this statistical representation efficiency is what we shall be observing throughout this whole course. And then with this comparison being done, next lecture we shall be looking at the color options that are available within Seaborn and backed by matplotlib. So these are multiple tips and tricks regarding the colors that we'll keep sharing in addition to next lecture. And then we will plot various types of the Seaborn features. So till then, we are going to do our happy visualizing. And see you guys back in the next video lecture.